Hello.
Good evening, Prof.
How are you?
Hi, sir.
Good evening, Professor.
How are you all doing?
Hey, Professor.
How are you all doing? All right, today we'll be working on, we're completing this topic today so that tomorrow we'll start with probability. By sharing my screen. I want to show you something before we start.
Good afternoon.
Good afternoon. How are you? All right, let's see. I'm logging into your class. Okay, this is your class. And I made an announcement about the things that are due this week. My announcements, you see, we have 3 assignments due this week. You have a discussion 4, and you have your first test, test 1, and also the Excel assignments. Now, for the reading materials, we complete what we are doing for last week. Then we'll begin on lecture 4, which is the introduction to probability. It is already in the files section, so you can find it from there. So this is what I want to show you, and then we can begin on today's lecture. The measures of position. 1 minute. So the measures of position, basically, they show us the position of data value in a distribution. Let me get something here. Make sure everything is ready for moving further. Yeah. So now we use these measures to locate the position or the relative position of a data value in a data set. Sometimes we call them fractiles. Well, the one that we use for measuring the relative position of data value in a data set. Sometimes there's the one we call fractiles, which are numbers that partition and other data sets in equal parts. Now, the one we call quartiles divide the data sets into 4 equal parts that are separated by Q1, Q2, and Q3. Okay. Can you hear me? Hello?
Yes.
I do.
So the Q1 is called the first quartile, Q2 is second quartile, Q3 is third quartile. There's another type that we call percentiles. We'll come to that in a minute. But the Q1 is the first 25 or the 25%. Q2 50%, which is usually also regarded as the median, as is halfway. And the Q3 is the 75 or 3/4 of the data that's in the set. So these are the one we're interested in among the 4 divisions for the quartiles. We're only interested in Q1, Q2, and Q3. So the percentiles, this one divides data set into 100 equal parts. Now, there is a relationship between the quartile and the percentile. For example, the quartile is, Q1 is 25%, which is the same as the 25th percentile, even though it is the first quartile. It's the same as the 25th percentile. Q2, which is the halfway, which is 50%, is considered the second quartile, which is also called the median. But it is the same thing as the 50th percentile. And Q3 is the third quartile, which is the 75%, 75%, and is the same as the 75th percentile, but it is known as the third quartile. But because of it is the same thing as the 75th percentile. So because of this relationship, we can use the same formula that we use for finding the quartiles to find the percentile. In this note, a different method was used for finding the quartile, but I'm going to show you the one method that you can use for both the quartile and the percentile. So that method involves using this formula that I'm about to write here. For the quartiles, we have, okay, let me open a new page where you can see more. I will be using that for getting our formulas. Okay, one will be the workbook, the other one will be for the formulas. So this is workbook. Now that formula is this: Q1. Let me this a little bit. All right, the Q1 will be the same as the 25th percentile. So I'm going to be using this formula. Q1 first quartile will be equal to n times p, n times p. Okay, you can say this. N times p over 100. So we can copy this.
Can you make it a little larger, Professor?
Yeah.
Let's say n times p.
Copy it. I'll paste it in our workbook. You can see it. I don't know why it's just not getting bigger. Okay, this is
Okay.
right there. So Q1 is the first quartile. So if you want to get second quartile, all you have to do is to change this Q1 to Q2. And to get the third quartile, you change it to Q3. You know. So we can use the same formula for percentile. In that case, we will just change the Q1 to P1 to P. So P, whatever, if you're getting the 25th percentile, you can use P to 25, you know. So you can see that only the name, this part changes, the formula part stay the same. So now, when we start using this, you understand it better. Let's see how we can apply this to this question. Look at this first example. It says here, number of nuclear power plants in the top 15 nuclear power producing countries in the world.
Can you unmute yourself?
So, can you mute yourself? Now, so the number of nuclear power plants in top 15 nuclear power producing countries in the world are listed. Find the first, second, and third quartiles of the data set. So this is the data set given. The first thing you do is to put them in order. You can arrange them in order from the smallest to the largest. So there are 15 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So they are not arranged. So let's find the Q1. Q1 will be, now, N is 15. Excuse me. Okay. Here, N equals 15. I make bigger. N is 15. Now, P, remember the Q1 is the 25%. P is, for Q1, that's the first quarter, N is use 25. Why do I use 25? Because when I was describing or introducing it, I showed you that for the Q1 is 25. That's why we use P in 25. So for this particular question, we can now plug this into the formula. That we have Q1 becomes N times P over 100. Let me put it right here. Q1, N times, and now N is 15. And our P is 25, 100, which is giving us, I don't know why this thing is doing this. Normally you can paste it and then increase it, but today is doing something different. Anyway, let me just make it as big as it can. All right. So we use N for 15 for N and P 25 for P. And that gives us from our calculator 15 times 25. We have 15 times 25 divided by 100. Give me 3.75. 3.75. 3.75. Now, each time you have a decimal part of here, like 0.75, round to the next whole number, which is 4, the fourth number. So that our Q1 now becomes we can count it from here. Our Q1 becomes, if you look at it here, the fourth number, you count 1, 2, 3, 4, 10. 10 is the Q1. So you can see it from.
Hello, Professor. Hello?
Yep.
Hello, I'm confused where you got the 15 from.
15.
The 15.
You count the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 numbers. That is your N. So N is the 15. You see it?
Yes, great.
Then P is 25, which is because we are doing the first quarter. So once you put it in this formula and count, you get 3.75, which can round up to the fourth number. And that is 10. So that Q1 is 10. What does this mean? It means that because Q1 is the first 25th number, it says, excuse me, you have 25% or less of this country have 15 nuclear power, 10 nuclear power nuclear power stations. You can see the way I wrote it here. You can see the Q 110, about 1/4 or 25% or less have 10 nuclear power stations. Can you see it? I see right here.
Yes.
Okay. Now, for Q2, you do the same thing. N is 15 and P is 50. Remember, why do I get P 50? Because I told you here that Q2 is the 50th halfway, which is 50, or the 50th percentile, which is the second quartile. So here, P is 50. So you plug it in. N times P over 100, I mean 15 times 50 over 100, 15. Okay, let me clear this. 15 times 50 divided by 100. You get 7.5. And 7.5 is the same as, well, like I said, whenever you have a decimal part like this, you round up to the next number, which is 8, the 8th number. So that Q2 will now become, you count, 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th number, and it's 18. So we say Q2 is 18, which means that about 1/2, or because Q2 is halfway, 1/2 of these countries have 18 or less nuclear power producing stations. Okay. Now, that answer the part 2. The part 3 is Q3. In this case, N is still 15, but this time P is 75. Then you plug it in. 15 times 75 divided by 100 give you 11.25. Now, which round up to, remember, this is not the actual rounding. You're just going to the next number. Because otherwise, in algebra, 11.25 will round to 11. Am I right or wrong? Hello?
Yep.
In algebra, 11.55 will round to 11. Am I right? Because
Yes.
2
It's less than 5.
Yeah. So, but we are not round, you are going to the next number, which is 12. So,
Okay.
now if there's no decimal part, I will tell you what to do. And the next another example when there's no decimal part. But so long as there are decimal part, just go to the next number, which is 12. So that Q3 now becomes, you count 1, that's the 12th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 31. It's 31. So about 75% of these countries have 31 or less nuclear power plants. Questions?
No, sir.
Got it.
Any question else? Who else? Somebody want to ask something? So we are good. Okay, good. Now, this leads us to what we call interquartile range, which is IQR. IQR simply means the difference between the third quartile and the first quartile. You look at here, we get our first quartile as Q1 is 10 and Q3 is 31. IQR means 31 minus 10. See? So you can see it's right here, Q3 minus Q1. So look at this here. It says, find the interquartile range for the data set that we just have. Just do Q3, which is we got Q3 as 31. 31 minus 10, which is 21. Questions? Excuse me, class. This is very important. Hello, Professor.
Good afternoon, Doc. How you doing?
Fine, how are you today?
Good. How are you, my man?
Fine, thank you. Can I call you back? I'm having a class now.
Okay.
All right, thank you. Sorry about that class. He's a professional colleague and they wanted to ask me something. All right, let's see. So the interquartile range is simple to get. You just get the Q3, get the Q1, and subtract it, and then you get the interquartile range. So this answer here means that the number of power plants in the middle portion of the data set vary by almost 21. So next thing we're looking at is the box and whisker plots. Now, this box and whisker plots is a kind of a chart that's a pictorial way of showing the minimum data entry, the first quartile, second quartile, third quartile, and then the maximum entry, which we call all these things that I listed: minimum data entry or lowest value, first quartile, second quartile, third quartile, and the maximum entry, which is same as the highest value in the data set. So all this, because there are 5 of them, we call them 5-number summary. So with the box and whisker plot, we can show these 5 numbers. So let's do one of them. Example, it says, find the 5-number summary of data set. Construct a horizontal scale that spans the large. Okay, this is just how to do it. I'm going to show you how it looks like here. You have the minimum entry, Q1, Q2, Q3. The line here we call it whisker, just to whisker. Now let's see our example as we did. Suppose we are asked to find the 5-number summary of this data value. That's what we have here. So suppose you are asked to find the 5-number summary of this. We already have the values for Q1, Q2, and Q3. So I'm going to write them down. Our Q1, if you look at this data entry, we have the lowest number there is 6. So L is 6. And the Q1, our Q1 is 10. Q2 is 18. And Q3 is 75. And then when you look at it again, the largest number we have here is 104. Largest number is 104. Now we can make the chart like we have here. So I've listed them down. Okay. In this case, they gave you the number. Q3 is 31. I will say 31. All right. So you can see it right here. You can see you make a box like this one. So first of all, you make a line from 0 because the largest number is 104. You make it from 0 to 110. And you draw this box. I'll show you how you can draw it. First of all, go here. Okay. You have 0. Hope you can see this. Can you all see my screen?
Yes.
10, 20, 30, 40. Now, the new version of Excel we have now can do this, but I don't have the latest version. But if you have the latest version of Excel, you put the numbers, it will give you the box plots. 50, 60, 70, 80, 90, 100. Now, if you look at the largest number in our data set, you can see that the maximum data entry here is 104. So because of this, we can go all the way to 110. Okay, all the way to 110. Or is it? Oh, right here. I think it's here. 110. And you can then down a little bit, and then you can now begin to draw. Usually, like I say, in the classroom, it's much easier to show this on the board. You can draw this line. Make it thick. I can make it a bit more good. Now, your Q1 is, you look at the Q1, I usually start with Q1. Look at our Q1. Q1 is 10. So Q2 is 18. Q3 is 31. So Q1 is 10. So I'm gonna draw the 10 right there. This is 10, so I can put right here. For Q1, 10. Q2 is 18. 18 gonna be somewhere here, right here. So I can just put it right there. 18. So I'm gonna draw it from here. I'm gonna draw the line. I think I can use a box and then turn it. I don't know. We see. Then Q3 is 31. Q3 is 31. 31 should be around here. So I'm gonna go all the way down here. 31. So that's gonna be our Q3. Okay, 31 should be from here. Yeah, my diagram will not be so perfect like the one you have in the textbook. Now you can now join this, okay, to form the box plot. Okay, now the tallest number here, so the largest number here is 104. So, and you can see here the 104, I can just draw it here. 104 should be around this neighborhood here. So from here, I'll go all the way to 100. You're now in 100. 104 should be here, 104. So we can just put a line. So you draw I'll call it the whiskers. So I'm gonna make it 104 right here. I'm gonna making it shorten it a little bit. Okay, so I can remove this. Then the lowest number there is 6. So 6 should be around here. I'm gonna put 6 here and draw the line. To 6. Okay. Whiskers to 6. So this is basically what they did in that chart. You can see how it is drawn. So I can now show you what we have in the paper. See? So you can see that according to this box plot, see the 5 number summary we are looking for here is 1, 2, 3, 4, 5 numbers. No, this should, you can see that this part of the chart is stretched more on this side than on this side, so that we can see that the data set is skewed to the right. I'm going to show you how to write it. you can say that because it is stretched more, the box is bigger on this side. So you can say that okay, interpretation. This data set is skewed to the right. Because this part of the box is bigger than this part. And you can see that very clearly that this is an outlier. It's standing out. So, and has one outlier. Okay, outliers. I'm going to put L here, outlier. Okay. So that's another way you can interpret this. And here it's true that the scores vary are between 10 and 31. By looking at the data, the length of the right whisker, we can conclude that 104 is a possible outlier. Any questions? Any questions, class?
No.
So what screen is you doing that on? Is that's not Excel, that's Word.
Which of them are you asking? Is it the one where I drew it myself, or on this one?
The one you did it yourself.
It's a Word. It's Word.
Okay.
All right, let's see. Mr. Ford, can you mute yourself? Yes, thank you. Now, so now we can look at the other fractiles. We have done the quartiles. We have done the percentile. We haven't done the percentile, yes. Now, the deciles divide data into 10 equal parts. So now, why we're not going to do decile is because once you get you have this formula. Once you have this formula that I used, I showed you this formula. See this one here. So if you are looking for the decile, dividing the data set into divide data set into 10 equal parts. I mean, D1 will be 10, D2 will be 20, D3 will be 30. So you just change, if you want to get any of them, just change P. Let's say you want to get D2, you change this P to 20 and then plug it in. So once you have this formula, you can use it for decile, percentile, any of them. So now let's look at the percentile of for data sets. Percentile. Now, percentile, like I explained before, divide the data set into 100 equal parts. There are two ways you can find two types of questions we ask about percentiles. The first part is we ask you to find the percentile. The other one will ask you to find the percentile rank. So either way, if you are looking for percentile only, you can use this one. And if you're looking for the percentile rank, you use this one. So you have, for the percentile rank, you have number of values below X divided by total number of values times 100. Now for the percentile, just N times P over 100, the same formula we use for the quartiles, where P is the location number, and then N is the number of values, total number of values, and the P is the percentile. Now let's look at an example. Say a teacher gives a 20-point test to 10 students. The scores are shown here. So you say find the percentile rank or the score of 12, find the percentile rank or the score of 6, find the percentile rank, so find the value that corresponds to the 25th percentile, find the value that corresponds to the 60th percentile. So now, excuse me. The first thing we do is to put them in order from the smallest to largest, which is what I did here. 2 is the smallest, followed by 3, and so on and so forth. And to find the percentile rank, use this formula. Percentile rank is number of values below X S is the rank. Sorry, is the number that you are given to find. You're going to use to find the percentile rank. Plus 0.5 divided by total number of values. This 0.5 is just a part of the formula. Now we have, let's say that you are given yes, it says find the percentile rank or the score of 12. So this becomes your X. Say S is 12. And how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. So N is 10. So percentile rank becomes number of values below X. X is 12. How many numbers are less than X? 12 here. We have 1, 2, 3, 4, 5, 6. So you can see right here, 6. Plus 0.5, which is part of the formula, divided by total number of values, which is 10 times 100. So we can have it here in this form. 6.5 and 6. Okay. 6 plus 0.5 divided by 10. Okay, then times 100. 65. This is the 65th percentile. 65th percentile. So we plug in, that's why I got the 65th percentile, which means that the student whose score is 12 performed better than 65% of all the students who took the test. Just like credit score, you say that your credit score falls in the 25th in the 50th percentile or 70th percentile. That means that your credit score is better than 75% or the 75% of US population. Now, questions on this? Any question? Any question, class?
What does the 0.5 represent?
Well, you are moving from what I call this discrete to continuous. So this is a correction factor. It's just a part of the formula. Correction for continuity. I'll put it that way. So because so for that correction, then I use the 0.5 as part of the formula. So it stays in the formula as a correction factor. Since you're moving from discrete to continuous, but variable. Percent is a continuous. Yeah. Any other question? Any other question for me?
No.
Let's see. I'm saying who is OR? Who is OR? Uptime. Okay. Yeah. Okay. Let's see. Just give me 1 minute. Let me see. Okay, I've answered it already. Now, 0.5 is part of the formula. Now, is next thing is the second part of the question says, find the percentile rank of the score of score of 12. So you say find the percentile rank of the score of 6. Now again, we have our X as 6 and N is 10. So the formula says number of values below X. This time our X is 6. How many numbers are below 6 in this score? 1, 2, 3. Number that are less than 6. So you gotta put here 3 of them plus 0.5 divided by 10 times 100. So again, we go to our calculator, we have 3. So I'm gonna change this to 3. I'll get 35. So this will now give us 35th percentile. So which means that the student whose score is 12, actually this is whose score is 6. I wrote 12 by mistake. This is 6. Whose score is 6. Perform better than 35%. This is 35%, not 65%, 35% of all students who took the test. So a student whose score is 6 did better than 35% of all the students who took the test. This 12 and 65% are typos, so don't use that. Now, part C is a different question. It says, find the value that corresponds to 25th percentile. This means to find the 25th percentile. In that case, you use the formula for the percentile, which is n times p over 100. This time p 25, that means 25th percentile. So our p is 25 and n is 10. N is the number of values. P is 25th percentile. So you plug it in here. N is 10, p is 25, divided by 100. Excuse me. Just like we did in quartiles, we get 2.5. Remember what I told you? If you have a decimal part, just go to the next number, which is 3, the third number, so that the score that corresponds to the 20th percentile is the you count it from here. 1, 2, 3, which is 5. So the value 5, see, is the 25th percentile. So now you can see when you don't have a decimal part, like here, it says find the value that corresponds to the 60th percentile. When you plug it in, you have 60%, p is 60, and n is 10. So we have from the calculators, you have 60 times 10 divided by 100. You get the number 6. There's no decimal here. See, there's no decimal. So whether you are computing quartile or anything at all, if it's quartile or percentile, so long as there's no decimal part, what you're gonna do is we get the 6. That is gonna be the 6th number. You go one more step. The 6th and the 7th number divided by 2. Let's say that your answer here is 5. Then you're gonna do the 5th plus the 6th number divided by 2. So long as there's no decimal. But if there's a decimal, like here, just go to the next number, which is the 3rd number, and then count it out. But here, there's no decimal. So you're gonna do the 6th number plus the 7th number divided by 2. So here, the 6th number is 1, 2, 3, 4, 5. This is 6th number plus the 7th number, which is 12, divided by 2. So that will give you the answer. The 6th number, which is 10, 7th number 12 divided by 2 is give you 11. So this 11 corresponds to the 60th percentile. Any question on to this? Any question?
Yes, Professor.
Yeah, go ahead.
Yeah, I want to ask, how can you tell if the question is asking for percentile or is asking for quarters? Because it's not stated in the question.
Hey, look at the question here. It says, find the value corresponding to the 25th percentile. So it is stated. And it says, find the value that corresponds to the 60th percentile. So if they want it to be quartile, they can say, find the first quartile. See? So they will mention it in the question. Like if you look at the one that we did when we are trying to find a quartile, like here, it says, find the first, second, and 3rd quartiles. So they will say it so that you know that you are looking for quartile this time, or that you are looking for percentile. Now, either way you are doing it, you still use the same formula because quartile and percentile have relationship. First quartile is the same as the 25th percentile. Second quartile is the same as the 50th percentile, and 3rd quartile is the same as the 25th, is the 75th percentile. Any other question? Miss Dolly, you have any more question?
No, sir.
Okay, good. Now, interpreting quartile, look at this quartile. This is a score, a quartile, a graph of the, this type of graph we call a frequency, cumulative frequency graph, or what's it called, a guide. It says the guide represents the cumulative frequency distribution of for SAT test scores of college-bound students in the recent year. What test score represents the 62nd percentile? And how should we interpret this? So what you're gonna do is 62nd, that means you're gonna go from here. About this is 60, you can see the percentile is 60, 70. So 62nd should be around here. You follow it all the way to where it touches this graph. Then from there you go down. Any score it touches here becomes the answer. As you can see from here. Look at the score. And the score it touches is the 1600. So the 62nd percentile corresponds to a test score of 1600. This means that 62% of the student has SAT score of 1600. Or you can even say this way, that 62% of them or perform better than, sorry, let me put it this way, that's how many of them, about, it didn't give us the numbers for the students, but they have a score that is perform better than 2% of all the students who took the SAT exam. So if you locate the 62 from here, go all the way to the curve. Wherever it touches the curve, follow it downwards. Any score it touches here become the answer, which is the 1600 score. Now, I think the last measure of variation we'll be looking at will be the standard score. This is the easiest of them to calculate. And we are going to meet the standard score again when we start doing normal distribution. The standard score, it says, represent the number of standard deviations a given X value falls from the mean. So it shows the number of standard deviations that it falls away from the mean. So this formula is this: value minus mean divided by standard deviation. The value, we use X to represent the value, minus the mean. Of course, we made this when we are doing the mean of a distribution. And then this is population standard deviation. So let's look at this. It says in 2009, Heath Ledger won Oscar for Best Supporting Actor at age 29 for his role in the movie The Dark Knight. I don't know how many of you watched Dark Knight. I haven't watched it either. But anyway, this guy he featured in that movie, and based on his activities in the movie, he won the Oscar. Penelope Cruz won the Oscar for Best Supporting Actress at age 34. Her role in Vicky Cristina Barcelona. Then the mean age for all Best Supporting Actors is 49.5 with a standard deviation of 13.8. And the mean age of all Best Supporting Actress winners is 39.9 years with a standard deviation of 14. Find the z-score that correspond to the ages of Ledger and Cruz, and compare the results. Now, all you have to do is to put them in, write out the values for X and mu and standard deviation, then solve it out. Then, for example, for Heather, he won it at the age of 29 years. So your X is 29. And for men, the mean was 49.5. So you put it right here, 49.5. That's for the mu. And the standard deviation was 13.8. So for the standard deviation, you put 13.8. Then you work this out on the calculator. So you have, write it down. Okay, 29 minus 9.5 but 10.8. So now you can go put in their calculator. You can say, all right, got with 9 minus 49.5, okay, divided by 13.8. Negative 1.4855, which is negative 1.49. So for this one, negative means that it is below the mean. Positive means it is above the mean. So you can say that the header's age is 1.49 standard deviation below the average age of winning the Oscar for that group. Now you can then repeat the process for Penelope Cruz. For Penelope, she won it at the age of 34 years. So that for Penelope, X is 34. And for the female, for the best supporting actresses, the mean age of winning that is 39.9. You can put 39.9 here. And the standard deviation is 14. You can put it here 14. Then you subtract and then divide, like we did here. So you're gonna do 39, 34, 34 minus 39.9 over 14. So we got 39.9 minus 14. So you got 39.34, actually 34 minus 39, 9.9 divided by 14. Negative 0.4214 and so on and so on. So you got to run to negative 0.4. When it comes to standard score, we stop at the second decimal place, which is negative 0.42. Again, negative means that it is less than the mean. So and positive is the mean above. So the mean age in which for Vicky Cristina Barcelona, he won it at a mean age that is 4.42 standard deviation below the average mean of winning that Oscar. That means both of them won it at a very lower age than the normal age range. Questions?
No.
Any questions? Good, very good. So now we can now round up by now showing how to compare the standard scores. I remember I mentioned that any score that is above 2 standard deviation. In my last class, in my previous class we had with you, any score that is above 2 standard deviation, we say that it is unusual. Say very unusual scores. Very unusual. This is very unusual. And then I'm sure you guys must have heard of this phrase. Let me write it down, because when I say it, some people they start asking me what I mean by that. I've heard companies talking about getting to 6 sigma in terms of efficiency. 6 sigma. When they say that, what they mean that they're trying to attain efficiency, whereby the number of errors will go as far away as 6 standard deviation away from the mean. That is very extreme, very unusual. So that means that when a company has reached that 6 sigma, means that their efficiency is very high, that the rate of committing an error is very, very slim. So that's good 6 sigma. So now, but the usual scores from 2 standard deviations and below are the usual score. Unusual score from anything above from 2 to 3, but very unusual. That means like talking about more than 3 standard deviation above the mean. That's when you start talking about 6 sigma. So Now, both when you apply this to scores of header and cruise, you can see that header is header is 1.49 standard deviation. That means that the score is still within the usual range, which is -2 and +2. So neither score will be considered unusual because they are still within the usual range. This one is -1.42, which is still fall within the usual range. Any question before we conclude for today? Any question before we conclude for today?
No, sir.
Oh, let me take your name and then
I have a question.
Yes, ma'am. Go ahead.
So about the test one, I think you said we have to do it and then on a separate paper, you have to show your work and show your photo ID and take a picture and upload that in Canvas.
Yeah, well, actually, let me open that.
I didn't understand what you wanted us to do.
The only thing I want is, when you do your work on the computer, right? You
Right.
use paper to solve it and then put your answer in. Am I right?
Not really, but yes.
Like now, we are solving it in Alex, a question in Alex, question 1. You solve it on paper and then type it in. Type the answer in. Am I right?
Sure, yeah.
So that each question you solve, write a number, and whatever you do on paper, that's what I want it to be uploaded. That's all I need.
Okay, you don't need the photo ID and stuff
No,
like that.
No, I don't need the photo ID. I need just for you to upload this here. All those papers that you use those scrap papers that you used to write, you solve, they get your answer, and then you typed it in and check it. And so those that paper, when you finish it, you can take a photo of it and then upload it here for me. You see, so that's here, this place.
Okay. For the midterm, do you have to do the same thing?
For
the midterm exam.
We're not going to have midterm exam.
We're not?
No, we're not having any midterm. Any score you have halfway of the class is your midterm.
Okay, I got it.
We're going to have test 1, test 2. See, if you look at it, you are seeing it here because this is my page. In your own page, you cannot see the midterm. Right? Am I right?
Yep.
Yes.
But you're seeing here because that's why I'm not going to put it up. You're going to have test 1, test 2, then several, maybe 4 quizzes, then final exam and the project. Okay, and then homework. So that's what I need. Don't put your photo ID. I don't need their photo ID. Maybe I have to go and update that part.
Hello, sir.
Yes.
Hello. In the Excel assignment,
yeah.
I don't understand what exactly are we supposed to do there?
What am I asking about?
The Excel assignment. I saw Excel assignment 1.
Assignment 1, okay.
Yeah.
It says that for you to do the platform asks you to use Excel to make a frequency distribution table. Okay, they gave you these numbers. So it says here, as a matter of fact, it has done the work actually for you. Okay, you did the work, you followed the steps and did the work for you. But I want you to do it, and when you finish doing it, it will have. When I click at your answers, I can see what you did. So it's already done, but I want you to do it. Do it and still upload for me. Then I can check it.
Right. During the Excel assignment, right? There was no direct command for the frequency. So I had to just copy it from the worksheet because
no, you can't copy it. Let me show you. You're not here when I showed it last time?
Yeah, because I didn't have the functions that they used in the worksheet in order to find the frequency.
And I had a go ahead. I'm sorry.
Let me finish with Missy. So you say you didn't have what again?
The resources or the functions in order to find the frequency.
Oh, you did. Yes, you did. Let me see. Sorry. Yes, you do. Let me see.
I know,
Esther,
but that one was like it was.
Esther have all those things. You have to look. What you're gonna do is the version of Excel you are using. Excuse me. The version of Excel you are using, you can check for it and maybe I don't know the version you are using, so I can only show you with my own version. But if you can know the version you are using, you check for YouTube and or I forgot to put the tutoring link to tutoring center, so I can show you how to put the command in the version of Excel you are using. Like if I'm using this one, if I look at this one, suppose I want to put this in that form. I have to.
Can you show us how to find the frequency in Excel, please?
Yeah, I'm about to do it now. Let me see. Let's say suppose I'm using this one. Can you see the screen?
Yep.
Let's say I'm using this data set. I'm gonna make these things to be only excuse me, 1 decimal place, 0 decimal place, so that you can let me make it 0 decimal places. No, okay. Now suppose I have this, right? Now I can sort it so I can know the largest number here and the smallest number. I think I'm gonna change some numbers so that they're gonna be, let's say 2, and then let's say this one is 8. Okay, I want to make the raw data, create a raw data. Okay, 7. Okay. Okay. Let's say this one is 26. Maybe I want a data that is completely random. You know what I'm gonna do? Let me generate a random number here, right? Data set that is random at random. So I'm gonna take you to this paper. Okay, maybe I will use this one. Yeah, this should be this is perfect. Let me run a total random number so you can see it. Let me make it big. Now, see mileage. So I can highlight it and say, okay, let me see which of number is bigger. So I can sort it out, It's just to find the number that is largest and one that is smallest. See, the smallest number here is 5. The largest is 70. Now, suppose I want to use this to make a frequency. Excel uses a different method, totally different from, not total, well, different in a way, because they call it bean. Call it bean. So in the version of Excel you are using, it is also called bean, but you have to figure out how it is done. Maybe you can try this way that I'm doing now, see if it's gonna work for your Excel. Now, the smallest is 5, largest is 70. If you're using an interval of 5, let's say you're using an interval of 5, you can say start from 5, and that's class width of 5, 5, 10, 15, 20, 25. Now, if you want, you can use the interval of 10, 5, 15, 10 intervals. 10, 5, 15, 25, 35. If you want that, so the width becomes 10, 10, 10. But I'm using 5. So 30, 35, 40, 45. And if one is set to draw a histogram after you did that, you can even ask it to draw it. 50, 55, 60, 65, 70. So it will give you this intervals. Yeah. Now with this, you can now get your frequency table. So first of all, you click on data. Now you see something here that is called data analysis. If it's not there in your Excel, you have to put it in there by yourself.
How do you put it there by yourself? Because I don't have that.
Okay, if you don't have that, means what you're gonna do is to go, once you go into your Excel, you go to File.
What?
Then go all the way down. You see what you have, options. Can you see that?
Yep.
Options. Then you can now look at where you have add-ins. Can you see that?
Yep.
Click on that. Then click OK. Okay. Oh, once you click add-in, it brings this out. See set add-ins. Do you
Yep.
see this? Click go. Do you do that?
Yep.
You can see analysis to pack. Check them. See, my own is already checked.
Mm-hmm.
Then when you check, they click OK. And then when you go back, you see it right there.
Oh, okay.
Now,
Once, go ahead.
Once it's there, now you can use it. Now you can say now once you have your number and your bin, then you can now go click on data and click data analysis. It comes out. It will bring up a dialog box. From this dialog box, choose histogram, and then click OK. Now the input range is your mileage. That's all these numbers here. So click on the input range so that you can put all the numbers in the input range, all the way to the last one, 70 number. Then, okay, click here. Now for the bin range, that's the width. Start from here to 70. Oh, excuse me, my mistake. Bin range. Bin range from here, okay, to 50 to 70. Now, once you have that, now because when you're picking up this mileage, you also picked the word mileage, and you pick the word bin. So you gotta check the labels. Now, for your output range, output is where you want Excel to draw the chart for you. I mean the frequency for you. So you click on output range, then you can choose any. I can say place it here. Then you can now click if you want chart output. If you want a chart, maybe a line graph, it can give you line graph, but I don't need that. You just need the frequency and the histogram. So you can put it right there. So if you want to see, that's what Excel will give you. So yeah. So, and if you want it to do it in a way that you have a free a histogram, then you can. There's a way you can do it as well.
Mm-hmm.
So I'm gonna upload. Hopefully this thing recorded very well. If it recorded very well, I'm gonna upload the video for you so that you guys can watch it over and over and then do it. Okay. Go ahead.
If you already submitted it, can you resubmit?
Yes, of course, sure.
Okay.
Go ahead and submit it. You're talking about the past due one, right?
Yeah, the Excel one.
So what you're gonna do? Try to submit it again. If it doesn't allow you, then let me know. I will.
Okay, I got you.
So let me take your names before you leave. I got Rita Ford. She's here.
With a question.
Miss Rita, I sent you an email. Did you get my email?
I got the email, but I couldn't open it. I didn't see where I could open the document.
So what you're gonna do? Remember that thing I used to send text message? Oh, I also sent one to a private email as well, because you gave me a private email.
Right.
You can check it. But usually I have that problem with students before, especially when they send me email from Canvas and I sent a document to them, they say that they can't open it. So that's why I ask you guys to put your cell phone in that in remind, so that when I send a message, it come to you as a text. If you had done that, I would have attached it to a message to you, and then you can open it. So you can still go and accept that message I sent, so it make it easier for you to get documents that I sent to you. Okay.
I'm going in there.
Now, Kishan.
Okay.
Kishan, okay.
Yes, I'm here.
Okay. So I took your name, so see you next tomorrow. The Bista, I have yours here.
Mm-hmm.
Bista.
Have a good day.
You too. Who is OROP time Anastasia? Who is Who's that? Oh, I think it's
I don't know if
Steve.
it's me. Is it calling on me because I'm not in Maryland right now. I'm in Atlanta. I'm using my
Your name is Juliana Oji, yeah?
yes.
How come I don't have this in my name, my list?
No, yeah, it's me. It's Dolly.
That's
Um,
Dolly, Professor. She
Sir?
said Dolly. That's
It's
Dolly.
Oh,
Thank
Dolly.
you.
Okay, Dolly.
Sir.
Oh, Dolly. Oh,
Yeah,
she,
I'm in Atlanta right now, sir. I'm
okay, I
using
can
my
see.
sister's phone. Yeah.
Okay. Now,
Thank you.
Rita, Debbie,
So I have it. So
who's Debbie?
Yes.
Debbie's here. Okay, I got you, Debbie. Then Walker.
So Darby has a question. I'll wait till you do attendance though.
Okay. With Walker, I saw with Walker, Tiffany Walker.
Walker is here.
Kent, I got Kent. Then who else? Excuse me. Vanessa. I got Vanessa. Vanessa, I can't see it here. Oh, I see it. I guess I have everyone now.
Sir, do you have Dolly?
Yeah, I have Dolly, yes.
Okay.
Walker is here.
Walker. I have Walker, Tiffany Walker. I have you already. So Walker, are you the one that have question for me?
No.
Oh, Debbie. Okay, Debbie's here. Okay. So, what do you have? If I call your name, then you feel free to leave. You are done. So, Debbie, you can now ask your question.
So I did this assignment yesterday because when I went in and I clicked on Excel assignment 1, this was the assignment that was there. And I noticed this Excel assignment 2, but that was the assignment when I clicked on the link. So I did this assignment yesterday.
Let me see what you mean by that. Excel assignment 1 is this one, right? You can see my screen, can you?
Yes, but on my screen, that's not what I had.
Don't have Excel. See, look, this is the assignment 1. See, it shows here.
Right, but you see where it says Excel assignment 2?
Yeah, but it's actually is because it is saved on PDF. Probably that's why I couldn't change this number 2 here. But
it's the same assignment that you just put up. That's the one I did yesterday.
Yeah, that's Excel assignment 1. It is considered Excel assignment 1 for this class. If you look at the Excel assignment 2, when you click on that, it will be showing as Excel assignment 3. But that's for this class, is considered as Excel assignment 2. Okay,
I just wanted to make sure I did the right assignment. And I also received your text, but when I tried to go into the remind, it says that I need a code, and I don't have a code.
you don't need the code. Once you get my text, reply yes. That's all you need to do.
I did that.
If you reply yes, if you put you in the class, you don't need the code. If you want to use remind, maybe if you want to use it for yourself, then it might ask you for that. But for me, all I need you to do is to respond yes, so that you can get my messages.
Okay.
All right, I think I'm done with you guys.
Professor, when is this due? On the 18th?
Yes. On 18th, yes.
Okay, and just put it into the Canvas.
When you finish, upload it for me.
Upload it, right. And then we'll print it.
All right, since there's no more question, let me let you go. And I'll see you tomorrow.
All right. Thank you. Have a good week, evening.